Okay, we're going to be kicking off the third installment for the Evo Wagon project to get dual ECUs running. Good news straight up, the vehicle now runs, starts and drives. So I would like to initially just say a massive thank you to a contact that I recently came across, Brett. He runs a small company called Mr. Connectors. He provides a lot of factory Evo connectors along with a lot of other manufacturers, and without his help I may not have been able to get to where I am as quickly as I did. So really cannot underestimate the amount of guidance and information he was able to provide to get me to where we are now. So yeah, massive thanks to Brett. And basically we're going to go through some of the stuff that we came across and some of the fault finding process. So we'll walk through some of that now. In the last video, we're at the point where the vehicle was running, had rerouted or routed the wideband controller along with the vac hose line. The situation with the two ECUs were all engine controls being done by the Nexus, stock ECU doing or intending to do gearbox control, and the only signals I'd split at that point in time were the plus 12 volt and the chassis grounds, which I'll go through the wiring diagram at a later stage, but I'll show you those ones. Still up for debate on whether those are going to be required when doing a stock ECU with a aftermarket ECU dual configuration, but at this point in time it's just being left alone because it's currently running and working. So what was happening, could start the car, could select reverse. There was quite a bit of a shock when that gear was selected. Neutral was fine, and could also select drive. However, there was no drive number, and then Tiptronic also didn't function. Yeah, went for an initial drive just after the car got running. Yeah, you could definitely feel a lot of slip because the transmission was in a higher gear, like second, third, potentially something like that. And yeah, just did not want to shift. So yeah, not ideal for the gearbox. So the speedo was also something else that was not functioning. So I already had one signal that definitely had to be split because it was an obvious sign to that with nil working speedo. Get the car home and yeah, tried to find people who knew people because something they had done, and yeah, finally got a hold of Brett, which was fantastic. So we're going to go through some of our fault finding procedure here. This is the wiring diagram for the 9 GTA. These pins 41, 42, 47, 48 were ones that I already split between the two ECUs. That was just in the car park after the car got running, and definitely knew that vehicle speed needed to be shared. So it was a case of what else was required to get the transmission back functioning. So there was always a reasonable amount of information to say that the TPS had to be shared, and I was traveling down that path anyway, but it was a case of what was going to be extra. So during the fault finding process, also this relay here is a key thing. So I'll explain a little bit about that relay in a bit, just a bit of a walkthrough. So yeah, messaging, phone conversations, that sort of stuff. And Anthony Dean was another bloke that I reached out to. He does a lot of work on the automatic gearboxes for these things, who eventually put me on to Brett. So another thanks to him. So just up front, we kind of determined that there's a couple solenoids in the gearbox, which are, you got these pin 77 and pin 89. These are an output power source. So you got gearbox, solenoids and obviously a power source to drive that solenoid. And then that allows you to shift the cars, those two solenoids. And then you've got all the individual like gearbox controls over here. So they're a main component, and that's a main component. And obviously we need to determine on how to drive all of that system. So that relay that I just mentioned is this relay here. So it's under the little skinny fuse cap, and it's identified, if that decides to flip it around the right way. So you've got relay E there, A/T, automatic transmission. And obviously that's the third one down. So 1, 2, 3, 1, 2, 3. So this guy here. So initially tried grounding out this relay. So in the vehicle here, you can probably see that bright blue cable there in the small blue connector. That's the relay wire. So the initial fault finding Brett put me down was to earth out that pin. So I made some early attempts to try and stick a wire in there, and just really wasn't working too well. And then some miscommunication between each other over messages. Just interpretation on my end kind of just didn't go well, so we ended up going to verbal conversation, and it sped the thing up a lot faster. So tried earthing out that pin to this bolt here. That was a pretty solid earth point. And he goes, you should hear the relay click, which it did. So that way you know the relay was working. He goes, yeah, once it's earthed out, you should be able to get some gearbox control back. Now, I didn't leave the ground on. I just basically touched it there, thinking that was just going to reset the relay or do something. And obviously the car didn't drive at that point. So back to the fault finding. Then, we tried a couple of different things with that wire. We kind of knew that the relay was working, and then kept going down the fault finding path of, well, we're manually signaling the relay to work. However, all things considered normal, there would be a bunch of signals going to the stock ECU and something driving that relay. So it was a case of, all right, well, we know the relay works, so it's like, what requires the drive to that relay to just, when you turn the key, the transmission control component within the stock ECU goes, all right, I've got this signal and I've got these ones, activate the gearbox. So originally we thought the gearbox was in limp mode. I believe the indication of that is if like the neutral light is flashing on the dash. So they kind of gave me some hope that maybe the ECU wasn't just completely cooked, or at least the transmission component anyway. So I was like trying to figure out what that was. I came across, I think I mentioned one of the previous videos, an Eclipse forum of some guy, I think it was like back in like 2008 or something, who got an Evo 8 ECU working in an automatic Eclipse. So similar thing, but just using stock Evo 8 ECU for engine control, the stock Eclipse ECU for gearbox control. And there was like a ton of signals to be split. There was like 8, 9, 10 signals. So I ran through those with Brett, and he's like, yeah, that's probably not required. That's probably not required. However, one that did flag up was the pin 98 12 volt ignition. So on here, this guy here. So we're like, all right, well, that's probably potentially going to work. So when you got the key in the barrel, it's off. Go to accessories, go to on, and then when you crank and start, that's the activation signal to this relay, and then that goes to pin 50, and then the output of whatever the control section in the ECU is doing for the gearbox sends power out these two, the 7789 out to here, out to the gearbox. And that was the catalyst for getting everything to run again. So, yeah, it took us a couple of days of backwards and forwards, and yeah, just a few phone conversations, but we ended up nutting it out, just having a bit of a logical think about things. Actually, I can show you in the vehicle here. Please excuse the wiring, it is exceedingly temporary. And so if this is all the original like 12 volt and grounds that are split between the two ECUs, there's potential these are output 12 volt and output 12 volt and ground, sorry. So they may not be required. That's something that Brett's going to investigate later because he's working on another project. So you can see in here that these, I'm trying to keep it reasonably color coded just for visual representation and my own tracking. Not that I don't know what's on which pin anyway, but these green boys here, that's the TPS signal coming in from the stock loom, and then having to split the TPS signal between the two ECUs. The connections that I did here basically strip back the ends on these wires and used, I think it was like 3 small zip ties to basically attach it to the original Mitsubishi Evo pin connector. And I was able to kind of validate that it was a reasonable solution because got an aftermarket ECU, so I can slap my computer into it and see that I've got TPS input and like variation. So I knew that that was going to be a suitable connection to utilize just for testing purposes. The other one that we had to do was the vehicle speed, so that was a gimme. Again, something that was I saw referenced across the internet. And then this bad boy here, which is the plus 98, or correction, 98 pin, giving plus 12 volt ignition. And you can see, I think it's like pin 98 on this connector, and then pin 99 on the factory ECU. But split that. Got all the battery hooked back up, and basically I got into the car when accessories went to on. Definitely heard a lot more random clicking and shit like that otherwise hadn't heard during the fault finding process, so it sounded promising. I put foot on the brake, put it into reverse, and then heard a whole bunch of solenoids trying to activate in the gearbox. So I kind of got the warm fuzzy at that point that we were going down the right track. So yeah, put it back into park, started it, selected reverse. The massive clunk that I got when selecting reverse was now gone. Went to neutral and then held my breath and then put it into drive, and sure enough the number 1 flashed up on the dash, and I was like, fuck yeah, absolutely over the moon. Yeah, just went for a bit of a slow drive around the estate because again the engine's not tuned. Wideband is doing the majority of the control at this point, just keeping the air fuel safe. I think I got up into about 3rd gear. I don't think it liked the very low throttle input with the very low speed in those gears. But in drive, it was quite smooth and didn't hear any funky noises from the gearbox, so that was also very promising. But this is, yeah, pretty much where the majority of the journey ends for this particular project. Again, I would not have got here as fast as I did without the help of Brett. He's been around Evos and Mitsubishis and 4Gs for, I think he's saying like 20-25 years or something, and I cannot understate like how much his experience and expertise has helped in this particular instance. So if you are chasing a lot of factory OE type connectors and some of those electrical type components, then hit up his website, Mr. Connectors. That's Mr. spelt in full. I did find on there he sells these retention clips, so I might actually have to hit him up and buy a couple of those, to be honest, after I saw those on his website. But yeah, he sells like, yeah, the factory like TPS a whole bunch of other connector housings and stuff like that for OE applications. It's quite a little good hidden source of parts. It was quite cool, and exceptionally knowledgeable dude. So coming back to here, I keep electronic records of all this stuff. I keep it on a shared file in Google Drive, which I will put a link down below, so that way people can at least view and download this information for their own personal reference. So there is no specific 9 GTA kind of like wiring diagrams out there, but for the most part it is very, very close to a 7 GTA. All the color coding on most of these pins I have verified. I believe I went through at some point and checked these colors, but be wary, they may not be completely accurate, but I think they're okay. Again, do your own due diligence. So what do you need to do a dual ECU conversion in an automatic Evo 9 wagon? Likewise, you could probably apply the same principles to a 7 GTA, but I personally haven't done it. The 41, 42, 47, 48, 12 volt in the grounds. I've done it. Brett has previously done it with a dual ECU set up in a 7 GTA. We're not completely sure if this is a compulsory requirement, but we've both done it just for whatever reasons. Throttle position sensor, mandatory. Vehicle speed, mandatory. And the 12 volt ignition here, mandatory. Now, there are other signals going back into the stock ECU, stuff like the ACD. I'm not plumbing that into the Heltec because the Heltec doesn't use it, and a lot of the documentation even states that as well. So seeing as how I have the stock ECU, then you may as well utilize it to its full advantage. But that should get you going. Now, a lot of people try and do builds and stuff on a budget. I get that. I understand that. Not everyone can afford an expensive aftermarket ECU. So if you wanted to do 2 stock ECUs, I couldn't provide that information to you on what would be required to split them between the 2, because you're now dealing with 2 stock ECUs, so both of them could potentially have a hissy fit depending on what they do or do not have. Likewise, the requirement to split potentially more signals between the 2 to basically activate everything required in both ECUs. I don't know how people may want to proceed down that path, but at least you've got the bare minimum here using an aftermarket ECU and a stock ECU. So again, it should help people down the path of potentially wanting to do this on a budget as well, which I completely understand. Likewise, a lot of people in fact are of the opinion that the stock ECU is okay for them, which is also fine. More power to you. If you can read it, you can understand it, you can write to it, you can modify it, then you do you, boo. So I will try and get a short clip of putting around, but at this point I've got to wait for some connectors to tidy up that wiring, because I do want it to be mildly more permanent and nothing to go wrong on the dyno day, because again, dyno tuning is expensive, it takes up people's time, and the faster I can get this up and driving, the quicker I can get back into it and enjoy it again, which is what I'm all about. The other thing that will happen during the dyno tune is replacing or getting a new cold side top intercooler piping. So you can see there's a massive bloody rubber elbow there, and then joins down there somewhere. I can't remember if it goes into I think there is a lower cold side as well. But getting a aftermarket custom made top intercooler pipe, because the autos are a bit different. But the purpose of that will be to, on the airflow, the mass airflow sensor, pull out the intake air temp wiring and route it to the intake air sensor that was provided by Haltech with the plug and play kit. So that way, because at the moment the intake air temp sensor is pre-turbo, so that will in essence just read whatever the air temperature is in the engine bay. Best case scenario, it'll be ambient, but obviously it gets bloody hot underneath here. So the engine will be trying to do fueling for a temp sensor pre-turbo. So obviously that air that is sucked in here through the filter into the turbo, into the compressor housing, out the compressor housing, along the hot side, through the intercooler, and then up into the engine, right? So that air has a lot of way to go. However, it was measured here, so it's not the greatest. What you want to do is measure it right before it goes into the throttle body. So that way, the ECU knows, okay, I have got 30 degree air, I've got 20 degree air, right before it goes into the plenum and then into the motor. And that way it can go, all right, well, the air temperature is a little bit cooler, so I can add a little bit more ignition timing, or I can add a little bit more fuel. And it just makes it, again, a little more economical, a little more stable, which is, yeah, where I'm trying to go with this, to try and make it efficient, if that's even possible for a 4G63 head. But trying to make it the best of what I've got, and hopefully be able to run the car for a while and kind of see what the fuel consumption figures change to. So again, as a bit of a recap, I'm running about 12 litres per 100, 98 octane fuel, and the motor is knocking like a motherfucker. Like, the guys Driven Motorsport have not actually been able to get a full run on the dyno with this thing. That's new plugs, cleaned fuel injectors, new narrowband sensor, new air filter, very good compression ratio motor. This thing's up to a bit over 170 across all cylinders. So it is a very tight motor, and they are still getting some pretty wild knocking. Like, they haven't been able to make a full pull on this engine setup. So that already means it's not running efficiently with the stock ECU doing engine control. So hopefully these few little modifications be able to tune it for efficiency. Whatever the power is, I really don't give two shits. It'll be more than the factory, obviously. When they did pull out of the dyno run for this thing, it was sitting at about 130 kilowatts, which is about expected. And I think it was at about 16 pound. So, yeah, can't wait to see what a full pull is like once it's all tuned, what the boost is at, how the boost is behaving, because I don't know how the wastegate is at the moment, if it's bloody boost creeping or it's cracking early, the blow-off valve's leaking, whatever the case is. So, yeah, getting it to a more solid baseline as well, just for further progression and development. And that'll probably be it for a little while. But yeah, new top mount pipe, full tune, and got to get all the connectors and stuff in. So this will probably be the last video for a little while, and then come back with how it's all running. So again, part of this is just being to document how I've been traveling with the project, things that I've come across, things that I've learned, and try and get this information out there. Like, this is still a complete Evo 9 platform. These are still very good cars. The gearbox is definitely a little underloved, but you work within your constraints, and you can still pull some moderate amount of power out of these things and still be fun and still be drivable and still be usable. So yeah, trying to take that veil down of like, oh, you have to modify the stock ECU, you can only get so far with it, and then yeah, at least this gives people another path. Hopefully you've learned something. Yet again, another massive shout out to Brett and Mr. Connectors, and yeah, hopefully see a few more of these projects out on the road. So till next time, thanks very much for following along for this little series, and yeah, if you're working on your own, post a comment down below. Otherwise, yeah, see you next time. Yeah, I'm currently running a Nexus S series ECU. I got a phone call from Heltec, I think it was a few days ago, basically stating there was going to be a recall notice out for these things because there was something internal grounding out and just basically wasn't ideal. So all that process has been pretty smooth so far. All the emails stating, hey, we're going to send out the kit, here's the recall notice, please reply with this email once it's all finished. But I just wanted to just quickly document kind of what the issue is, just visually on a surface level here. So taking the back plate off already. The instructions, I haven't checked the video, but the instructions are pretty well written, which is fantastic. Here's the original back plate, and here's the replacement. So you can see that there's a slightly milled out area, and I'm going to assume it's because of whatever point that is. I'm assuming it might be to sandwich the PCBs together. I'm assuming there was not enough space, because apparently the issue originally stemmed from a couple of reports of guys like roll cage mounting these or chassis mounting these things and basically squishing the chassis together, causing it to ground out, which if you don't know anything about electronics, the magic smoke, I assure you, never goes back in. So yeah, going to get all this back together, and now I can kind of, since I've been doing all the vehicle stuff, I've kind of been having to disconnect the battery, pull the ECU out, and it's just been a bit of a pain in the bum. So now I can kind of just leave it all connected rather than having to continuously disconnect it all the time. But got a little fresh washer to go onto there. Other than that, it's all pretty straightforward. Happy days. Car is running. The ACD function still works. Car's currently in park. So normally when I would go to reverse, there would be an absolute massive clunk from the gearbox. I'm not too sure if the audio came through in that, but that was all pretty smooth and normal. And then during the fault finding process, I could get to neutral and then to drive, but the number 1 wouldn't appear. It would just get the green D, and then going across the Tiptronic, there would also be no numbers. So yeah, so that was basically after I put that 12 volt ignition line in, basically got everything to function. So that's basically where we're at now, and just go for a little short trip.